Today we're going to look at lesson 6.2, which is still solving by substitution. Today we are going to look at taking what we talked about yesterday and doing one extra step to it. So the process of substitution can occur even if neither equation starts with an isolated variable. Okay, so remember that was our first step when we were thinking about the substitution process. We want to look for a variable that is completely by itself. So if that's not the case, to determine the best variable in which we'd have to solve for to get that variable by itself, we're going to look for a variable whose lead coefficient in front is the number 1. All right, so we want a 1 in front of a variable. Or basically, if it's a 1 in front, that means that you don't see any number in front of that letter. So let's look at several examples. So our directions say to solve the system by substitution and then check your solution. Well, if I'm looking at this equation, we've got 2x plus y equals -4 on the top. On the bottom, we have 5x minus 2y equals -1. So right off the bat, I don't see an equation where it says x equals or it says y equals. So that's why we have to first get a variable by itself. So like I said, we want to look for a 1 in front. If we look at the top equation, there's a 2 in front of that x, so that's not what I want to solve for. Notice the y, we don't see a number in front. That means it technically has a 1, and so that would be a variable that we could solve for. If we look at the bottom, there's a 5 in front of that x, and there's really a -2 in front of that y, so neither one of those variables would be good. So we actually want to take this top equation of 2x plus y equals -4, and our first step is we're going to get the y by itself. So to get y by itself, we move whatever is not, is on the same side, we want to move it to the other side. So positive 2x, we are going to subtract that over to the other side. So now we have y equals, those are not like terms. It doesn't matter which you put first. I'm going to put the -2x and then say -4. All right, so that's technically the equation from the top. So we still have this bottom equation of 5x minus 2y equals -1. So technically, this is the system that we look at. We have this now equation where we have a variable by itself. So now we can go ahead and do the substitution process. I'm going to take what y equals and I'm going to substitute it into the y in that other equation. So we're still going to have 5x minus 2, but now in parentheses, instead of y, I'm replacing it with 2x minus 4. And then I have to finish the rest of that bottom equation. This equals -1. So now we have an equation with only variables of x, which is exactly what I want. I want only one variable. So now I have to start solving. So because I've got parentheses, there's a number out in front I have to distribute, but be careful. It's a -2 that has to get distributed. So it's not just 2. So we're still going to have the 5x, -2 times -2x. Well, -2 times -2 is +4, and there'll still be an x with it. -2 times -4. Negative times a negative would make that a positive. 2 times 4 is 8. So that still equals -1. We've got some like terms. We've got some x's on the same side. So 5x plus 4x tells us that we really have 9x on the left. Now I want to start solving for x, so I'm moving numbers that are not connected first, so that +8 gets moved over by subtracting. So now we have 9x, and that equals -1 minus 8 is going to give us a -9. Last step to get x by itself, I divide by 9, and so a -9 divided by a +9 would give us x equaling -1. Remember, that's not my final answer. When we're talking about a system here, we have x's and y's. So I found my x, but now I have to figure out what my y value is. So now, remember, that means I'm going to take the value for x. I'm going to go back to that original equation that we had that y by itself, and wherever I see that x, I'm going to substitute that in. So we're going to have y equals -2, but now I get to replace x with that number we just found, which is -1, and then we still have -4. So when I start simplifying, we have to multiply. -2 times -1. Negative times a negative makes that positive. We'll subtract 4 from it. Well, 2 minus 4 is going to give us a negative 2. So that's what y is. So our solution is an ordered pair. X goes first. We got that to be negative 1. Y goes second. We got that to be negative 2. Now, remember, going back to what our first lesson of this week was, or I guess of last week, we're going to want to make sure that this solution really is valid. So you will always know if your answer is correct by going back and checking your solution. So if we check, it doesn't matter if you go back to the original problem or if you go back to then this system that I have down here where we got that variable by itself. I'm probably just going to go back to the original problem here. So we're going to have 2, and then I'm going to substitute in my x value, which was negative 1, plus, then I'm going to substitute in my y value, which is negative 2, and I want to know, does that really equal negative 4? So let's double check. 2 times negative 1 is negative 2, plus negative 2. Well, negative 2 plus negative 2, that does get me negative 4, so that checks out. Now I have to check that bottom equation. So we have 5 times x, but I get to replace x with negative 1, minus 2 times my y value, which is negative 2, and I want to make sure that that equals negative 1. 5 times negative 1 is negative 5. When I then multiply, we have a negative 2 times a negative 2. A negative times a negative makes that a positive. 2 times 2 is 4. Notice that negative 5 plus 4, that will get me negative 1. So I just quickly double checked that the solution that we had truly was the solution, which is why I'm able to circle it. And I know confidently that yes, negative 1, 2 is my solution. All right, so if we take a look at this next example, if I look at my equations, we've got 3x minus 2y equals 2, and we have x plus 2y equals 6. So starting off, I don't see x equals and then something, and I don't see y equals and then something. So I know that I have to do a little bit of manipulation. I want to have a 1 in front of a variable in order to solve for that. So if I look at the top, there's a 3 in front of that x, there's a negative 2 in front of that y. The top equation is not the equation that I want. If I look at the bottom equation, I have an x and I don't see a number in front. That tells me that I really have a 1. So that means that, hey, I'm going to take this bottom equation and I am going to solve for that x because there was a 1 in front. So to get x by itself, I'm moving anything that is not connected to the x. So that means this 2y, I have to move it over by subtracting. And so now we have x by itself. 6 and this 2y are not like terms. It doesn't matter how you put it. So I'm just going to say 6 minus 2y. All right, so that means we still have that top equation of 3x minus 2y equals 2. So technically then this is the system. We got then this equation where our variable is by itself. So that means that I get to take what x equals and I get to substitute that into the x in that second equation. So we'll have 3, and then in parentheses, I get to replace x with 6 minus 2y. Finishing the rest of that equation, we'll still have minus 2y equals 2. Because I've got parentheses and there's a number out in front, I'm going to distribute that 3. 3 times 6 is 18. 3 times negative 2y would give us a negative 6y. We still have minus 2y because that was not in parentheses, and this still equals 2. So now we have an equation where all of my variables are the same. They're all y, which is exactly what I want. So now I want to start solving for y. With these on the same side, negative 6 minus 2, that means that we get to combine those y's. We really have a negative 8y. I want to start solving for y, so that means I'm moving numbers away from it that are first not connected. So that's why I subtract 18, because remember, positive, I want then the opposite, so a negative. So we still have negative 8y. This equals 2 minus 18 is going to give us negative 16. And then finally, we're going to divide by negative 8 to get y by itself. A negative divided by a negative is a positive, and 16 divided by 8 is 2. But that's not my final answer. Because I know that we have y, I have to go back and I have to solve for x. So that means I'm going to take that 2, I'm going to plug it back into the y in the equation that we have the x isolated by itself. So now we're going to have x equals 6 minus 2 times 2. Well, 2 times 2 is 4, so we really have 6 minus 4. So then we get a value of x to also be 2. So that means that we think that our solution is the ordered pair 2, 2. But until I absolutely check my answers, I'm not going to circle that solution. So I have to go back. Like I said, you can go back to the system that you just created down here, but I think it might be easiest if we go back to the original. I have to plug in 2 for x as well as 2 for y. So with the top equation, we'll have 3 times 2 minus 2 times 2, and we want to make sure that that really does equal 2. Well, 3 times 2 is 6, minus 2 times 2 is 4. Notice that 6 minus 4 will definitely get us 2. So that top equation checks out. Now I'm going to that bottom equation. I've got x is 2 plus 2 times y, which is also 2, and I want to make sure that that really equals 6. Well, 2 times 2 is 4, 2 plus 4 is 6. That one checks out as well. So since both of them are true statements, we know that we solved that system correctly. Our solution is 2, 2. I would suggest that you pause this video for a second and just answer this checkpoint problem. It says state which variable is best to solve for. So when it says the best variable to solve for, you're going to say, okay, yes, x or y, and then you're going to tell me what equation. So it's either the top equation, which I would just call equation 1, or it'd be the bottom equation, which we call equation 2. So pause now, come up with an answer. All right, so hopefully you looked and you saw that in the top equation, the number in front of x is a -1 and in front of the y is a 4. None of those are positive ones, so the top equation doesn't work. If we look at the bottom equation, there's a 2 in front of that x. I don't see a number in front of the y, which really means that there's a 1. So it looks like the best variable to solve for is y, and that happens in equation number 2. So hopefully you are understanding the process with these 2 example problems. Try the homework, reach out if you have any questions, and we'll do more tomorrow.